Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. In this video I will explain the modulus and the argument of the product of two non-zero complex numbers. Let z1 equals r1 into cosine alpha plus I sin alpha, and z2 equals r2 cosine beta plus I sin beta, the trigonometric forms of z1 and z2. r1 and r2 are two positive real numbers. We have to multiply z1 times z2, and we call z1 times z2 equals z. We multiply z1 times z2, so z equals r1 cosine alpha plus I sin alpha times r2 cosine beta plus I sin beta. r1 times r2 alone, we have cosine alpha plus I sin alpha into cosine beta plus I sin beta. This is cosine alpha cosine beta minus sine alpha sine beta, the real part. The imaginary part, cosine alpha sine beta plus sine alpha cosine beta into I. So cosine alpha cosine beta plus I cosine alpha sine beta plus I sin alpha cosine beta minus sin alpha sin beta. The real part alone and the imaginary part alone, so we have cosine alpha cosine beta minus sin alpha sin beta, and plus I cosine alpha sin beta plus sin alpha cosine beta. So cosine alpha cosine beta minus sin alpha sin beta is cosine alpha plus beta, and cosine alpha sin beta plus sin alpha cosine beta is sin alpha plus beta. We have here a positive number r1 times r2 positive number, cosine angle plus I sin same angle. Then this is the trigonometric form of z. The modulus of z is r1 times r2, and an argument of z is alpha plus beta. This is r into cosine theta plus I sin theta. It means r equals r1 times r2, and theta equals alpha plus beta plus 2k pi. R equals r1 times r2, here modulus of z, here modulus z1 times modulus z2. Modulus z equals modulus z1 times modulus z2, and if we substitute z1 times z2, we get modulus of the product equals the product of the modulus. Argument z1 times z2, it is alpha plus beta. Alpha plus beta plus 2k pi. Then this is argument of z1 plus argument of z2. For example, if z1 equals 3 cosine pi by 6 plus I sin pi by 6, and z2 2 cosine pi by 3 plus I sin pi by 3, and z equals z1 times z2, modulus of z, that is modulus of z1 times modulus of z2, 3 times 2 equals 6, and argument of z equal argument of z1 plus argument of z2. This is pi by 6 plus pi by 3 mod 2 pi equals pi by 2 mod 2 pi. If we want to write z in trigonometric form, we write it as z equals 6 into cosine pi by 2 plus I sin pi by 2. Z is pure imaginary because its argument is pi by 2. Modulus and argument of a fraction. Z equals z1 over z2. We have to calculate modulus of z and argument of z. We transform this fraction into a product. Z1 equals z times z2. Since z1 is written as product of two complex numbers, modulus of z1 equals modulus of z times modulus of z2. Then modulus of z is modulus of z1 over modulus of z2. Argument of z1 equals argument of z plus argument of z2, then argument of z equal argument z1 minus argument z2. So when we have a fraction, modulus equal modulus over modulus, argument equal argument of the numerator minus argument of the denominator. Z1 equal 4 cosine pi by 6 plus I sin pi by 6, Z2 2 cosine pi by 2 plus I sin pi by 2, Z equal Z1 over Z2. Calculate modulus of Z and argument of Z. Modulus of Z1 over modulus of Z2, 4 over 2 equals 2. Argument of Z equal argument of Z1 minus argument of Z2 equals pi over 6 minus pi by 2 equals minus pi by 3 mod 2 pi. Minus pi by 3 is an argument of Z. Modulus and argument of a power of a complex number. Z equals Z to the power n. Z equal modulus of Z into cosine alpha plus I sin alpha. We are going to calculate modulus of Z, means modulus of Zn, and argument of Zn. Assume that n equals 2, Z equals Z square. Modulus of Z is modulus of Z square. Modulus of Z square is modulus of Z times Z equal modulus of Z times modulus of Z equal modulus of Z quantity square. So modulus of Z square equal modulus of Z quantity square. Argument of Z equal argument of Z2. Then this is argument of Z times Z. This is argument of Z plus argument Z equals 2 argument Z. And equal 3. Modulus of Z3 equals modulus of Z square times Z. And since here we have Z1 times Z2, this is modulus of Z square times modulus of Z. But modulus of Z2 equal modulus of Z quantity square, then this is modulus of Z cube. And argument of Z cube equal argument of Z square times Z equal argument of Z square plus argument of Z. Argument of Z equals argument of Z square equal to argument of Z. Then argument of Z cube equal 3 argument Z. Conclusion. Modulus of Zn equal modulus of Z to the power n. Argument of Zn equals an argument of Z. Modulus of Zn, so modulus of Z into cosine alpha plus I sin alpha to the power n. The modulus of Z to the power n is modulus of Z to the power n. And the argument is an argument, so cosine n alpha plus I sin n alpha. And in case of where modulus of Z equal 1, if modulus of Z equal 1, we get cosine alpha plus I sin alpha to the power n equals cosine n alpha plus I sin n alpha. And we can find many trigonometric formulas making use of cosine alpha plus I sin alpha to the power n equals cosine n alpha plus I sin n alpha. We will see that later on. Affix of a vector. We have vector u in the plane. Vector u. What do we mean by affix of u? We consider the point M in this plane such that vector OM equals u. Z of u by definition is Z of M. Z of M. Notice that M and U have the same coordinates. Let us see. So they have the same coordinates. X of U equal X of M and Y of U equals Y of M. Then the coordinates of M is the same as U. U of coordinates XY, then M of coordinates XY. Z of U equal Z of M equal X plus IY. Affix of vector AB. Here we have vector AB. To find the fx of a vector, we have to know the coordinates of the vector. How to find the coordinates of vector AB? This x of AB equals xb minus xa, y of AB equals yb minus ya. ZAB equals real plus I imaginary part. XB plus IYB minus into XA plus IYA. This is ZB minus ZA. Z of vector AB equals ZB minus ZA. A2 minus 1, B minus 3, 4. Z of AB equals ZB minus ZA. ZB, we substitute ZB, minus 3 plus 4i, and minus ZA, minus 2 minus I, equals minus 3 minus 2, plus 4 plus I, 5i, minus 5 plus 5i. Z of AB equals minus 5 plus 5i. And since we have Z of AB, we can calculate the coordinates of vector AB, which are minus 5, 5. Or we can calculate the coordinates of AB first. X of AB equals xb minus xa, minus 3 minus 2, equal minus 5. Y equals yb minus ya equals 4 minus 1 equals 5. Yb minus ya, yb 4 minus ya minus 1 plus 5. So ZAB, since we know the coordinates of vector AB, Z of AB equal minus 5 plus 5i. Another example, u equal minus 3, 1. Find the fx of u. The fx of u is minus 3 plus I. Example 3. Given A and ZAB minus 1 plus 2i, find the fx of B. How to find the fx of B? Z of AB equals ZB minus ZA. We substitute. So ZAB equal minus 1 plus 2i equals ZB minus ZA. Take minus ZA to the other side. We still have ZB equals ZAB plus ZA equals minus 1 plus 2i plus 2 minus 3i equals 1 minus I. Thanks for following and good luck.